Hey, Mr. Kaczynski here. IXL added a new skill in their 8th grade section AA, and it's called Solve a System of Equations Using Any Method. So, just a nice little review of the 3 methods of solving equations that we've learned. Really, I'm only going to use 2 of them though. Alright, so this one, I noticed the negative 7y and the positive 7y, and this is built for the elimination method or the combination method, where you add those together and you get 0y. 7x plus negative 2x is 5x, and 7 plus 8 is 15. Divide both sides of this equation by 5, and we've already got one value of the coordinate where these two lines meet. All right, so then we can take that 3, plug it into either equation. I'll just choose the bottom one here. We're going to do negative 2 times x, which we just found to be 3, plus 7y equals 8. So negative 6 plus 7y equals 8. Add 6 to both sides, 7y equals 14. And then divide both sides by 7 and you get y equals 2. So the point where these two lines meet is at when x is 3 and y is 2. Alright, next up, here's another one, and both equations in this linear system are in intercept form. So you could grab your graphing calculator and just graph them and look for where they intersect each other. I think that'd be a great way to do it. I'm going to do it algebraically here, and I'm going to do that since y equals 10x minus 10 and y also equals 8x minus 6, I'm going to use substitution method. So I'm going to replace that y on the bottom with 10x minus 10 since they're equal to each other. So that gives me this new equation that only has one variable in it, and I'm going to solve it for x by subtracting 8x from both sides, adding 10 to both sides, and then dividing both sides by 2. So now that we've got our x value, we can come back up to either equation. I'll choose this top one, and we can plug x in for 2, or substitute it. So 10 times x, 2, minus 10, which is 20 minus 10, which is 10. So the solution to this system is x is 2, y is 10. Remember, you could have used a graphing method for that. I would highly recommend it if you got a graphing calculator. If you don't, substitution method works pretty quickly. Alright, so this one I could do with substitution method. I could take this bottom equation, solve it for one of its variables, and then substitute it into the other. But I think I'm going to use the elimination method on this one. I'm just kind of partial to it, and I'm just going to multiply this bottom equation by 2. That'll give me 2x plus 2y equals 6. And the top equation, I'll just leave it alone, and I'll leave it as negative 2x minus 7y equals 19. So by multiplying the bottom equation by 2, the lead coefficients here are opposites of each other. They add up to nothing. Negative 7y plus 2y is negative 5y, and 19 plus 6 is 25. Solve that equation by dividing both sides by negative 5, and we get y equals negative 5. Then we'll come over here. I can plug that negative 5 into either equation, but I'm definitely going to use the bottom one. It's got no coefficients of the variables. It's going to be really easy to solve for x. So x plus negative 5 equals 3. All right, just add 5 to both sides, and we get x equals 8. So our solution to this linear system is x is 8, y is negative 5. Let's do a couple more here. Hang with me. It won't take me very long. So again, I would probably multiply the bottom equation by 10 here and use the combination method, but I think I'll take this opportunity to show you that substitution method here works as well. So I'm going to take this bottom equation and I'm going to solve it for y by just subtracting 4x from both sides. So y equals negative 4x minus 19. Then I'm going to take this top equation and I'm going to substitute negative 4x minus 19 in for y. It gets a little bit ugly, but it's repetitive too, so once you get good at it, it's not that bad. 3x plus 10 times y, which is negative 4x minus 19, equals negative 5. All right, so we got to do some distributive property. 10 times negative 4x is negative 40x. 10 times negative 19 is negative 190. 3x minus 40x, those can be combined to negative 37x. Let's add 190 to both sides. That gives us negative 37x equals 185. And then we'll do 185 divided by the negative 37, and we get that x is negative 5. All right, so we got one value. Then what I'm going to do is take that value, plug it into this equation. I can plug it into any equation, but this one's already solved for y. So when I substitute x in there, it's going to be pretty easy to figure out what y is. So negative 4 times the x value we just found, negative 5, minus 19, which is 20 minus 19, which is 1. So our x value is negative 5 and our y value is 1 of our solution. Remember, you can check these answers algebraically too. So let's just use some mental math. 3 times x. 3 times negative 5 is negative 15. 10 times y. 10 times 1 is 10. Negative 15 plus 10 is negative 5. So it works in the top equation. 4 times negative 5 is negative 20, plus the 1 gives us negative 19. So check your answers, especially as you get up into the challenge zone on IXL. One more, and I'm definitely going to use the combination method here. So I'm going to take this top equation, multiply it by 8. That gives me 40x minus 48y equals negative 32. And the bottom equation, I'm going to multiply by 5. So that's going to give me negative 40x. See what I did there? Plus 50y equals 40. All right, so now we can use the combination method because we've got leading coefficients that are opposites. Negative 48y plus 50y is 2y. Negative 32 plus 40 is 8. So y is 4. All right, then I'm going to substitute that 4 into the top equation. You can do either equation, but this has got a positive coefficient of x, and usually that makes it a little bit easier to solve for. So 5x minus 6 times y, y is 4, equals negative 4. 5x minus 24 equals 4. Add 24, negative 4. Let's not make that mistake. Add 24 to both sides, and we get 5x equals 20, so x equals 4. The solution to our system is x is 4, y is 4. All right, so you got the combination method, you've got the substitution method, and don't forget graphing method. If you got equations in slope-intercept form, that's a really easy way to solve a linear system too. And check your answers, don't forget about that. Good luck, and let me know how it goes in the comments.